Dear viewers, Shoaib Dayo is here with the lecture series of the electrical machine subject, and today the lecture of the electrical machine subject is the commonly used electrical machines in our electrical engineering. So the commonly used rotating electrical machines generally are the DC machines and the AC machines. The machines are categorized into the two your supplies, the DC supply that are called the DC machines and the AC supply that will be associated with the AC or the alternating current machines. Okay, so in the most commonly used your electrical machines are the DC machines, induction machines and the synchronous machines. Okay, DC machines are the work on the direct currents, okay, and induction and the synchronous machines are your alternating current machines. In these machines, the conversion of the electrical energy into the mechanical energy or mechanical energy into the electrical energy can be done by the coupling magnetic field. So first of all, we have to discuss the little bit the concept of the DC machines over here. The DC machine. As you can see from the board, in a DC machine, it can be a generator or the motor. Already we have discussed all these things in our previous lecture, that a machine can be your generator or the motor. Okay, it depends upon the power flow. That will be the reverse one, or that will be the, in the case of that, motor or the generator. Now the field winding is placed on the stator and the armature winding is placed on the rotor. In the DC machine, either maybe the generator or the motor, what happened, according to a construction point of view, the field winding is placed on the static part of the machine and your armature winding is placed on the rotating part of the DC machine. A DC current is passed through the field winding to produce the necessary magnetic flux in a machine. Obviously, we need to magnetize the field coils with the help of the external DC supply. So that will be called the separately excited DC machine. And if the machines are your supply itself, like your self-excited machines, means supply itself, there is DC currents, so that will be called the self-excited DC machine. So there are the different types of the your DC machines, separately excited DC machines and self-excited DC machines, in which the series machine, shunt machine and the compound machine. Later on we will discuss in our further lecture series. Okay. Now the main purpose of the field winding is to produce the magnetic field, produce the magnetic flux in the field winding, or that will be placed on the static part of your machine, and the armature winding is placed on the rotating part of the machine. So by changing the direct current in the field winding, we can control the amount of the magnetic flux in the field winding. If you are increasing or decreasing the amount of the flux in the machine, the field winding, what happened, the induced voltages which are produced in our armature winding will be vary. So your output of the machine can be increased or decreased. It depends upon the magnetism effect on the field winding. Okay, so the armature winding is the heart of the machine, because in which the voltages are induced. If we are talking about the DC generator, this winding, in the armature winding, the EMF is induced. So that will be called the induced EMF, or like in the generator action. Okay, and in the motor action, in the armature winding, the torque is to be developed. Okay, the voltage induced in the armature winding is alternating voltage. Always your DC machines cannot produce the direct current voltages, but connecting an assembly with your armature winding on the DC machine, so that assembly can be called the commutator, or that commutator can be defined as it is a mechanical rectifier which is used to convert the alternating voltages into the direct voltages, and that direct voltages can be obtained through the carbon bushes and supplied to the external load in the case of the DC generators. Okay. And in the case of the DC motor, these with the help of the carbon bushes, we are supplying the direct current supply to the armature winding of this your machine, and what happened, your motor is going to be your operated, and electrical energy is converted into the mechanical energy. So second part is your induction machine. In the induction machines, we are commonly or the popularly we are using the induction motors. Okay, in the induction motors, there are the two types of the induction motors: the three-phase induction motor and the single-phase induction motor. In the three-phase induction motors, as you can see from the construction point of view, a three-phase induction motor is comprises of the two parts, the stator part and the rotor part. Okay. The stator is comprises of the stator coils, which are embedded into the slots of the machine, in the slots of the stator core, and that will be called as your stator winding. That will be your stator winding service, both the armature winding and the field winding. The rotor can have the winding similarly to the stator winding, and the rotor winding if you are using the aluminum board and or the copper boards. So in the rotor construction, these bars are short circuited at the end of the slip ring, is the end of the rings. So that motor or that rotor, in the type of the induction motor called as a squirrel cage induction motors. Okay, and normally we are using the squirrel cage in construction point of view here. We are using the such type of the induction motor. Now, what is the operation of the induction motor? As you can see from the board, whenever this stator winding is to be energized from the three-phase supply, what happened? A revolving magnetic field has been established. The revolving currents, three-phase currents are established in the stator winding, and they are run at the synchronous speed. Okay, and what happened? There in between the stator and the rotor, there is an air gap. The air gap provides the movement of that your induced voltages. The currents are to be induced on the rotor winding of your induction motor, and hence according to the Faraday's law of electromagnetic induction, whenever a flux is linking with the coil, it changes, and EMF is induced in the coil. What happened? When stator windings are connected to the three-phase supply, flux is produced in the air gap and revolves at the synchronous speed, and the revolving flux induces a voltage in the stator as well as on the rotor side, and already the rotor is the enclosed or the closed circuit, and what happened? The current is flows through your rotor windings, and what happened? It's produced the sufficient amount of the torque to rotate the shaft of the rotor winding or the rotor of the induction motors. So this was the little bit intro of that three-phase induction motor. Now let's discuss the concept regarding the single-phase induction motor. The single-phase induction motor are work on the single-phase supply, and the stator carries the single-phase winding, and the rotor is always the squirrel cage type of the rotor. Now, a single-phase supply does not produce a revolving magnetic field in the case of the single phase motor. Now what we have to do in the single phase motor, we need additional winding to revolve, to produce the sufficient amount of the torque to rotate the shaft of your single phase induction motors. Okay, and to make it a self-starting torque, we should produce a revolving stator magnetic field. This can be achieved by converting a single phase supply to the three-phase supply. And what happened? This method can be done by providing the additional winding, and your single phase supply, if going to be converted into the two-phase supply, what happened? Your single phase induction motor will be the self-starting induction machine. Now, at the last, synchronous machines. Now, what are the synchronous machines? They are commonly used as a three-phase type, and in the synchronous machines, the rotor carries the field winding and the stator carries the armature winding. In the case of the synchronous generator, the prime mover is going to rotate the shaft of the synchronous generator, and it provides the mechanical energy. It generates the mechanical energy from that your prime mover's output, and that prime mover output mechanical energy is going to be converted into the electrical energy with the help of the coupling shaft, which is connected with the alternator of the synchronous machine. And then what happened, your field winding of your synchronous machine is excited from the DC supply, and your armature winding, in the case of the DC your synchronous machine, you are getting the three-phase alternating voltages from the your armature winding. Now the field windings are excited from the DC supply to produce the rotating or revolving magnetic flux in the air gap. A synchronous machine can be act as a generator, or the motor operates on the synchronous speed. The speed in the case of the synchronous generator or the alternator is maintained with the help of the prime mover and also the terminal voltage of your alternator, which are commonly used in our power plants to generate or to produce the bulk amount of the electrical power, and their terminal voltage can be maintained with the help of your field excitation voltage, which is given to the field winding of your alternating your synchronous machines. So this was the little bit intro regarding the basic your theoretical concepts regarding the commonly used electrical machines in our electrical engineering area. So as you can see from this diagram, this is the general construction of any electrical machine. So that any electrical machine comprises of like your rotor windings and the field windings, okay, stator winding. The stator and the rotor are separated by a certain air gap, okay, and you are like here, these are the pole shoes, okay, these are the field coils, okay, and this one is your rotor winding. And this if you are taking the example of the DC machines, here this one rotor winding is that armature winding, which is the rotor winding, and this is the stationary winding, which is the field winding, and the field windings or the field coils are embedded into the slots of your field cores on which the magnetic flux has been established. So this was the whole lecture regarding the commonly used electrical machines in our electrical engineering, and I hope that you have understood today's lecture regarding the general introduction of that electrical machines. And at the last, please don't forget to subscribe my YouTube channel Shoaib Dayo for more informative videos related to the electrical engineering area. Thank you very much.